introduction. So welcome to everybody. I think you, Tino, gave already a short introduction. Okay, today we have our webinar. Topic is functional safety and specifically safety requirement specification, which a document of a huge importance, but I'm not spending any word on that because I leave to our expert Tino the wording later. Just I want to make a short introduction about GMI, who's offering this free of charge webinar. As many other we are doing many webinars on different topics from functional safety, intrinsic safety, application of safety relays, or many other topics. So just follow our web and you will find a lot of topics of your interest. We are running these webinars since a couple of years, and we will proceed on that, and we will have further themes that we will follow up in the coming future. So just few words, because I took already too much time because of my delay, about GMI. What we are doing field interface, and we are very focused on safety, and that's why our equipment are either certified for functional safety up to C3 level, or intrinsic safety, or all of them, both of them in the same product. So you find GMI in different packaging automation like DCS, ESD, fire and gas, and in different industrial sector like oil and gas, from oil and gas up to food and beverage as well, where also safety is important. GMI is an Italian company. We are located in Italy, but we have different offices around the world. We almost cover the entire globe, either with the GMI office or subsidiaries, but even with a lot of authorized system integrator. We are about 200 people around the world. We have several thousand of installation around the world as well. Since today we are talking about functional safety, we also provide functional safety training, but again I will leave later on the speech to Tino, or I will enter into discussion with the training that we provide. Of course, dealing with safety, we have to be up to date with the technology in delivering and producing our equipment. We do test 100% before any equipment leave our factory, and that's also why we are so confident about the quality of our product, that we deliver our product with 5 years warranty. Again, keeping in mind that we deal with the safety of people, environment, and assets of our customers. Yeah, being safety company, we have, and quality company, we hold almost all necessary certification to produce our equipment, as well all the necessary certification to deliver our equipment worldwide. As you may know, especially when we talk about intrinsic safety, there are different standards, ATEX, ICX, but even country standards that need to be matched. And we almost cover all necessary certificates which are relevant to the regional installation as well. This is just a short introduction of our portfolio. As said, we are producing field interface, so we have intrinsic safe barrier, safety relay, as well as isolator, power supply system, multiplexer systems. We have a termination board, for customized termination board to connect straight away to the main safety system and DCS system available on the market. We have HART multiplexer, surge protectors, as well as local loop indicators. Last bullet is not a real product, but it is a kind of service that we provide to our customer. Services means consultancies, means training on the two main topics, again, safety topics like intrinsic safety and functional safety. Together with Tino, we are delivering several training on functional safety, Tino, which will generate and will provide to our trainee once they exceed the final test, a TUV certificate, which qualify people as functional safety engineer. This is just a short list of our typical customers, whether they are end user, OEM, or EPC contractor, or even, of course, system vendors. Just a few words about this presentation. You will receive this PDF, the PDF of this presentation over an email. And in case you will miss something or you want to review something, you will also find the same presentation recorded on GMI YouTube channel. Now I'm going to leave the speech to Tino, and just to mention that during the speech I will monitor the webinar, and if you have any questions, there is a button, question and answer, which you can use to raise question. I will interrupt Tino in the due moment answer. And last, we will have a final section of a question and answer. We collected your question during your registration process, and finally we will have 2 or 3 of these questions which will be answered by Tino. But again, if you have other questions, feel free to use the question and answer button. I will monitor that. Thank you again. Before to leave the speech to Tino, and sorry again for the delay and the technical problem I had to face. Tino, I leave to you.
Okay, thank you, Mauro. But there's a big echo, Mauro. I don't know if you hear it also. Maybe there is another system open. Maybe you can put it on mute. Thank you. All right, there will be during the presentation, there are a couple of interactions required from you. That means there will be like a list that we will ask you a question. You can click some of the answers that Mauro will also right, so today's topic is safety requirement specification. I think anyone in the industry working in the domain of industrial safety, I'm just listening if the echo still is there, but it goes down. Right, so anyone involved in safety projects or in engineering will know what is the key importance of a good document, of a reference document. In our safety industry, in the functional safety application industry, we call this the SRS, or Safety Requirement Specification. I start here with the first slide, which is the life cycle of the IEC 61511, which is the leading functional safety standard if you want to design, engineer, build, maintain, and operate a safety instrumented system in the process industry. What is process industry? For the standard applications such as oil and gas, chemicals, petrochemicals, pharmaceuticals, and also food and beverage. The last 2, pharmaceutical, food and beverage, were added in the addition to in the year 2016/2017. The life cycle itself is nothing more than a working principle. In other words, it's a method. It's a method explaining engineers doing step-per-step, systematic your activities. Make sure you can document them correctly. Make sure you can verify or check them correctly. And let's try to achieve a certain quality of the work you are doing. So that's the whole life cycle. And as Mauro is saying, we have been doing webinars for a couple of years now. I think it's the 3rd year we're doing the webinars. Many of them are, or all of them are recorded and are available on the YouTube channel, but many of them will cover different topics. Today, I highlighted here this box number 3, which we call in the life cycle phase number 3, or In this case here, it is described in clause or chapter number 10 of the part 1, which is a normative section of the IEC 61511. Coming back on the life cycle, I like to use the picture to explain you a short story so you understand what the document is all about. Any project worldwide is always starting to first try to find out what kind of hazards do we deal with. And once we start to understand the hazards, and once we cannot control our hazards, that means they're getting out of control, they may become a certain risk. So before we start to understand what hazards and what risk we have to do a hazard and risk assessment, which is the first step in any project. And most of the projects are using in the second phase, we will look on the existing installation, on the existing control platforms. Can we use a certain existing system to reduce that risk so we actually can live in that process unit or can work in this process unit without risking our life, simply speaking. That means that once we know our tolerable risk, and we're coming in our second phase, and we're looking at the allocation of specific safety function to specific layers, that is what we call the famous LOPA, or layer of protection analysis. And based on the risk reduction that we can achieve on specific independent layers, if there is still some risk residing in the plant, which is higher than it is tolerable or acceptable, that means we have to reduce even more. So when we have to reduce more, we have to define this. We have to define this that those engineers who physically will have to build it know exactly how to build that safety loop. We also have to describe it in the sense of that exactly the maintenance engineer will be able to maintain the system, mainly to do maybe some repair, to do some loop testing, to do some proof testing, to prove that the system is still working. And also in that same document, we have to give the relevant information for our operation team that they will understand and know how they can operate such a safety instrumented system. So that's all explained here in the second slide with phase 1, 2, and 3. And by memory, there is a poll section coming up here. That is where Mauro will come in, and he will launch the first poll. So I will read you the question. I would like to ask you a question before I start to explain the safety requirement specification. The ownership of such a document lays either with the safety consultant company that you may hire, or lays with the engineering contractor that you use to maybe engineer and build your plant, lays with the SRS integration team. They own, the ownership of the SRS lays with the integration team itself, or lays with the end user operating company. E, it's with the operation and maintenance team itself of that SIS, or it was the main automation contractor, or the MAX as we call them, or all of the above. I don't know, Mauro, if you can launch the poll, because I don't see it here. Your microphone is still muted, but something...
Yeah.
Okay.
To be honest, I launched already the poll.
Okay, I don't see it. Let me see if I can also do it here. Ownership. Okay, can you confirm that you see it now, Mauro?
I see it.
Okay.
And I asked you, can you confirm whether
Yes,
the echo is still there?
People are clicking. No, the echo is gone, but people are now answering it. I can see it's coming in. So let's give it a few more clicks.
Okay. Yeah.
I didn't know, Mauro, but I can also launch it over here because I got the same control bar as you probably are looking at. So not a problem.
The fact is that I was launching, but
okay.
Okay, let's wait a few more clicks and then we can stop the poll. Yeah, we have already good amount of answer. Let's stop it. You want me to share?
Yes, please. Okay. So the answers, as you can see over here, is that the majority of you have answered that the ownership lays with the end user and the operating company. which makes me quite happy because it is, of course, the only correct and valid answer which we are looking at here. Since the end user or the operating company or the corporate image of the company, they are responsible to maintain safety in their production facilities. That means the document, which is the safety requirement specification describing how you will try to prevent that items will happen because of a certain hazard occurring, but your SIS can isolate and can stop that. Well, that document, of course, the ownership lays them with the end users operating company and not with the contractors or not with the safety consultants that you may have hired. Because remember that if you as an end user operating company listening into this webinar today, you hire those people. It's your duty to make sure that you hire competent people to deliver you a document that you can actually still maintain safety on your production unit. All right, Mauro, I will stop sharing and I will close this and I will continue. Right, what are the general requirements now according to the IEC 61511 standard of such an SRS document? Well, the objectives is, as I said before, to specify your safety instrumented system requirements, loop per loop. That means SIF per SIF, or safety instrumented function per safety instrumented function, needs to be clearly described on how that SIF needs to be built, how it needs to be maintained, and how it needs to be operated from the operation point of view. It's not often a single document. The second bullet, it may be a single document, would be great if it would be. It has benefits, it has also disadvantages. If it would be a single document, most likely it will be continuously under revisions because there's always some small modification or changes coming in that you may have to open that document again and maybe add, remove, or do some different text in that document. I know that there are some customers, they have a kind of a method where they work with a general SRS about the general sections, and then they have a specific kind of a data sheet or a specific, let's say, format per safety loop. That means the benefit for that type of approach will be that if you do a modification on a existing safety loop, well, then you only have to modify one of that document, which is about the safety loop itself, and not the entire document where you may have multiple loops, maybe hundreds of that in one document contained. The SRS shall be written, that is kind of a no-brainer if you would ask me, but it shall be written to help the people to understand on how to use it and how to use that activity in the life cycle. According to the 61511 edition 2, which was released in February 2016, which was an amendment in 2017 around August time, well, if you go to the normative section, which is part number 1, if you would go to chapter number 10 and you go to 3.2, you will see that this will describe 29 bullets. And those 29 bullets are specific requirements per safety loop. So every single safety loop shall describe and shall include a specific description on what is the intention and the approach that needs to be used during development of that SIS safety requirements. But they have this killing, I call this here in blue color, I call this here the killing sentence or the killing word in the sentence to take the value away as applicable. If you tell an engineer, you shall do this, as applicable, and he tells you it's not applicable for me, he still fulfills the standard. So in other words, yes, you do have 29 requirements, but we do like to describe them as much as possible clear for people later on to understand on how to work and how to maintain that system. Of course, here in a very short webinar, as we do here today, we cannot describe those 29 items. However, we do have some good news for you. I have described the 29 items many years ago when it was still a draft of the revision 2 of the 61511 for GMI. And this is here the GMI book called the SIL Manual, which is the Safety Instrumented System. And if you will go to chapter number 8, in chapter number 8, you will see specifically the SIS safety requirement specification example of one safety instrumented function, or simply speaking, of one safety loop. And in that book from GMI, I have been trying, I mean, being an engineer, or being an engine nerd, as some would call me, I've been trying to just give you an example, potentially, what could be behind the description of the standard. So again, if you would have the book, and if you don't have the book, I'm sure that Mauro may tell you later, but you can send an inquiry about the book online on the website from GMI. So if you don't have the book, I would recommend to try to get a copy, and then you will see a practical example of a safety instrumented function or a SIF description. What are now the minimums? Well, in the minimum description is the safety function description itself of that safety loop. What does that loop has to do for you? First of all, the first question is always, what do you want to measure? Do you want to measure high pressure, low level, low flow, high temperature, whatever are the measurement? We need to describe that. So in that safety function description, we first start to say, what do we try to measure to identify that our hazard is just being initiating that trip point or that alarm? Second bullet is, what kind of interlock or logic narratives do we have to carry out once we have the high level? Maybe we have to start or stop the fill line. It would be stop the fill line if you have a high level in a tank, as an example. Well, then we will have to stop the fill line, we have to trip the pump, etc., etc. Those are all kind of actions that the logic will make sure that once you recognize your high level, what do we have to do? That means that what do we have to do is your final, let's say, decision of the safety loop. That can be a final element, it can be an MCC starting or stopping a motor. I mean, in safety, some people make safety quite complicated, but actually safety is nothing more than opening a valve, closing a valve, starting a motor, stopping a motor. With those two simple examples, I most likely have given you 99% of all your applications that you have been dealing with, so-called safety loops. Now, one of the more important items is how much time do we get between measuring the hazard and carrying out our final decision or our, let's say, final element action. How much time do we get between measuring to reaching the safe state? In other words, when I'm reaching my high level in my tank, how much time do I have before the hazard gets out of control, before my tank will overfill? As an example, that means that that specific process safety time towards the reaction time, and I do remember in the registration, one of you has given me a question which I did answer, so I will not do it now, but I will then show it. We have a specific rule on how to do that. Here, between brackets, it's a brief summary. The SIF response time, your safety function response time, is always to be minimum 50% or faster than the maximum allowable process safety time. And then the last bullet is, what is the performance we are looking at in terms of what is my risk reduction factor that I will try to assign to this safety loop, that if it works, how much risk can it reduce for me? In other words, how much frequency or likelihood it can reduce for me that this event will not escalate to become a risk. Some of the more easier one to understand is, per safety loop, we want to have one unique hazard description. In other words, what kind of hazard does this safety loop trying to isolate you from or trying to prevent you from? Second bullet, what are the bypass requirements potentially available or applicable on that safety loop? What was new by the edition 2 is, when you are talking about bypass, you only allow to initiate a bypass if you will compensate for whatever signal you are losing because of the bypass. That your bypass must be monitored, must be authorized, must be time limited. All these kind of things are all normal culture with a bypass. But what was new by the edition 2 is also the compensating measures. Another bullet which I like to highlight over here is the proof test implementation of that specific loop. What is the test interval? There are two different test intervals. One is the recommended test interval from the manufacturer. The other one is a test interval based on the performance that you try to achieve with your mission time that you will use that safety loop, hopefully inside the useful lifetime of your devices. What is the test coverage? For instance, how can I test a specific transmitter? How can I test a specific valve? Those are kind of items that needs to be described. Another topic which is also important for the edition 2 is the consistency. If you have 4 engineers doing all kind of the same test in the field, how consistent are their tests towards the results which they documented maybe in their test reports? Maybe some engineer has a shortcut that may not be documented. Those are all kind of items that we may want to look into. What are the assumed sources of demand of that SIF? In other words, what type of signal can trigger the interlock to be activated? Because when there is an interlock going to a safe shutdown, and it was a spurious trip, I'm pretty sure your production people will get very nervous, including your management. They want to start as quick as possible. So it's always very, very handy if you know exactly what kind of system can trigger my safety loop to stop. The mode of operations, we have low demand mode, high demand mode, and we have also the continuous mode. How do we start up the loop? How do we shut down? Where is the manual shutdown? Is that wired through your ESD, yes or no? That's very important to be highlighted. What is the reset? Once you went to a shutdown and your hazard goes back to normal condition, the interlock is no longer initiated, you should not re-initiate the output without a reset. So you need to foresee a reset unless your SRS said, we do not need that. Those are all kind of items that the SRS will have to describe. And of course, there are many more. I only mentioned here a handful, like 5, 6, 7 of them. There are more in the GM International Manual in that chapter number 8. Same topic on the safety requirement specification is also valid for the AP, stands for the application programming. When you program your safety PLC or you have your system integrator programming your safety and safety system for you or your safety PLC, what kind of information do you give them? Do you give them text? Do you give them narrative? Do you give them function block? Do you give them a mix of everything and a bit of nothing? How clear is that documentation going to the engineer who has to program that? Well, that's also here a clear definition from the standard. There is a clear relation, of course, between the logic inside the safety PLC with the type of platform, call it the type of system that you may use. It is clear that vendor A cannot be converted into a vendor B source code because they both may have a different compiler version, different CPU modules, etc. So those are kind of items that needs to be described also very clearly inside your application program specification. Yes, Mauro, we have a second poll. Let me see if I can share this again. Oops, I go back. Or maybe we are both sharing it. I'll let you do it, Mauro. I will not. Have you launched it?
Okay, I launched it, so
okay.
You should see. Please confirm that you see it.
Yes, I do see it.
Okay.
I don't know if other people
Looks
also.
like.
Yes, there is someone.
Yes. Yes.
Would you consider the safety requirement specification as? This is more like a general question. Would you consider the SRS as a design specification document? Would you consider it as an operational instruction document later on for the operators to know how to actually operate or work with that safety instrumented system? Would you consider the SRS as a maintenance instruction document, which will be part of your maintenance procedures? Would you consider the document the SRS as a self-verification reference document? Would you consider it as an as-built document, or would you consider the SRS all of the above, which is, of course, always the easy answer? All right, Mauro, we have quite some alerts.
Yes, we have enough click, so we can stop the poll and I immediately share the results so that you can comment.
Right. Well, we had here clearly some people think, well, the SRS, that's all from the engineering companies, that's clearly in a design phase. This is true. But remember, the ownership is with the end user. Because end of the day, you will have to use that document. So clearly, the operators need that, the maintenance people will need that. And if, for instance, you would like to do some self-verification on your specific, let's say, safety system or safety loop, Well, you need to have a reference document for that. I'm in discussion currently, very, very short story. I'm in discussion currently with a customer. They ask us, can you write for us a operating and maintenance procedure, because the insurance company is asking us to show them a procedure. So my blunt logical question to them was, can you please send me your SRS? And the answer was, we don't have this, Tino. And I said, how can you make a procedure, how to operate and maintain a system, if there is no reference document? So basically, the SRS is a backbone for everything. It's also your as-built documentation, because you will have to maintain the SRS for the duration of the life of the SIS. So clearly here, the answer we were looking for is all of the above, was here, well, we had 45%, so it's not enough. I would hope to have more there, but at least you see what is the, you know, in the instrumentation or in the engineering world, many people believe that this is only a engineering or design specification document, which of course is not true. Right, I got a very quick question coming in. How do you qualify the hardware software taking the correct action? I would like to answer, if I would understand the question better, how do you qualify hardware, qualify software taking the correct action? That's a bit of a generic question. Requirements on the hardware. Well, the requirements on the hardware, it depends on if your project needs to be in compliance with the IEC 61511, then the first thing to look at is, what road selection have you decided? Have you gone for road to H? That means, have you gone for the famous prior in use or prior use of your equipment by the end user data? And that will be then based on that data. You can simplify and stay on your architectural constraints into a certain design, if that is the specific question. If not, the alternative is you can ask your vendor 61508, what kind of road selection have they given you as documentation? Was it the road 1H? Well, then you will have to use a table from the 61508 in able to decide how many hardware do I need to achieve a certain SILAB. Again, we do have some webinar also on that. If you are interested, don't ask me the title, but it's something to do with the hardware fault tolerance webinar we have done, Maru. Maybe you will remember the title, but I may come up later on with it. Right, let me focus on...
I will check and I will give you later the name.
Okay. So some of the key challenges, what are now the difficulties? Because it's not all rocket science, it's not all 100% clear. The standard is a guidance. It's a good engineering practice, and they give you some guidance. And believe me, even though you may read the guidance, even though you may be a practical engineer of the standard, I'm pretty sure some of the bullets that I may have listed over here are also the key challenges of what you will see if you try to comply, regardless of the good SRS or not. So one of the items, the first bullet which I listed here is, since 2016 edition 2, the 61511 is requiring a functional safety manual, which is not the same as the safety manual from the vendors. Assume that you buy 5 different interfaces from GMI. They give you 5 different safety manuals, and your system integrator is installing those 5 GMI interfaces with 20 different other vendors' instrumentation, and they all have safety manuals. How do you explain to your customer with a customized document, which is called here the functional safety manual, if they look at this system, or let's say this safety loop functionality, how do you simply explain the functionality in terms of a functional safety manual? That's the first challenge, which I see still, let's say, weekly, monthly, daily, if we are on site with customers to see how they struggle from a practical point of view to have that document. The second question will be, who is responsible to make this? Well, it depends on who is building the system. If the system integrator is only building from marshalling to marshalling, he's not supplying you with the final element, he's not supplying you with the measuring sensors, etc. Well, then they cannot be held responsible to give you a full scope of the functional safety manual of everything. So that is the first question typically that people will struggle with. The second one is the cybersecurity risk assessment shall be carried out on your industrial automation control systems. How many of you here today know that this is part of the SIG 1511? It may not be part of your safety requirement specification, but it may have an impact to that, because some of the instruments or maybe some of the logic solver that you decide to use may be also vulnerable for maybe some, call it cyber attacks, or maybe call it some breaches into your security level of your system. It doesn't have to be a cyber attack. It can also be a person with a other intention other than maintaining or operating the system safe. They may have another intention with it. So those are kind of items that you have to be looking at also. Proof test coverage. How many of you listening in here today know that in the SRS needs to be a proof test coverage factor explained as part of your proof test implementation? And it's not simple taking the proof test coverage factor from the vendor, because what do you do when you combine 3 different vendors' equipment together? And by memory, it's also in the received questions during the registrations, which I made an answer for. The proof test interval. Again, the proof test interval, for instance, GMI has an interface, and GMI, because of the liability of the company, will tell you after 20 years, you shall perform this and this and this and this and this test. And if you do all this test, you may claim X% of coverage factor. Now, the proof test interval from the manufacturer may not be the proof test interval that your SIL verification program has given you, that you may have to test the interface from GMI, which the manufacturer only requires every 20 years. Maybe in your loop, you have to test it every 2 years. So those are kind of items that needs to be filtered down in the safety requirement specification. Because remember, that document will be the backbone of the safety approach of your safety loop to prove how good your safety loop is still working. Then we have the human factors in design, maintenance, and operation, which is a bit of a gray area, where I will talk about the key performance indicators or the KPIs. In other words, how will you estimate the human influence during the design, during the maintenance, and during the operations of that same safety instrumented system? That's also one of the challenges of the edition 2 of the SIG 1511. And on this slide here, that was also on some of the previous webinars which we have done, and I received from one of the experts in the field of functional safety a comment, which it was a correct comment, that I should explain it a little bit more clear in my webinar. So I will give it a try now today. Mean that the MTTR, which is standing now today for the mean time to restoration, that used to be called in the old edition of the standards, and I refer to edition 1 of the SIG 1508, which came up in 1997 till 2010. So since 2010 till 2023, so for the last 13 years, we changed that definition into a MTTR, that's the mean time to restoration. But the mean time to restoration in the IEC 61508 standard is only described in light of a diagnostic-based system. That was not mentioned in my previous webinar, so that is why I'm happy this is recorded and will be on YouTube. So I can send this link again to the expert that gave me the comment, which was a correct comment. So assume that you have a valve with no diagnostics. You have an actuator, you have a positioner on it. There's no diagnostics on the valve. Now, when will you know the valve is not working? Well, either when it is too late, that means your safety system is asking the valve to close, but your valve is stuck open. That means you cannot apply the same, let's say, formula as they show you over here, because here the MTTR is actually providing that the A time means that is the time to find out, to detect your failure. And detection is only by diagnostics. When you find the failure, we call that you reveal the failure. We don't say you detect the failure. Detection is by built-in diagnostics. It's automatically done by the manufacturer, IntelliGency built-in, and they can provide you with a safe solution, go to potentially a safe state. Example giving, when you have a safety PLC with diagnostic-based coverage on the digital output module, and for this digital output module would not be able to shut down the output channel, well, then the diagnostic needs to have a secondary mean to shut down, enable to remove the power to the field that you can go to a safe state. That's a clear example of a safe, let's say, decision based on a danger detected failure. Now, coming back here on the A time, the time that you find out, in your case, revealing, may be based on your proof test. So when I see a customer and the customer explained to me the minimum time that we will do proof test is always minimum 1 year. We don't want to do it faster because it costs us too much money. Now, when I then look into their SIL prediction verification program, and they fill in an MTTR for the entire loop, and they fill in 8 hours, 24 hours, 72, which is a 3 days weekend, 96, which is a very long weekend, that's the classical default value that people will fill in. Then I'm asking the question, do you think it makes sense to predict the unavailability of your loop if it takes you 8,760 hours, worst case, from year end to year end to test your safety loop? If you say you're going to repair it in 8 hours, because now repair is no longer just this time, this is the repair time, which is called the mean repair time, or the MRT. So in summary, the MTTR applicable for diagnostic-based systems, that is in the standard. But if you look in SIL verification programs, commercial packages available on the market, the MTTR may be limited to maximum field entry, or let's say the entry of field of number may be limited to 300 plus hours. And there is a reason for that. Okay. As GMI, as Mauro is saying, besides also selling products for GMI, we can support you, including with the TÜV Rheinland accredited competency review programs. Myself, well, next week I will be delivering another functional safety engineer program, which is my course number 218 by memory. And my counter is now at 2,711 people. So every week we are counting. We also deliver Fundamental of Cybersecurity, which is one of the newer courses that came on the block or came on our program portfolio in 2020. That was right on this famous year of Corona, or infamous year that the whole world stopped. We also had the AACS Cybersecurity Risk Assessment, or the SRA course. So those are the two new courses that we deliver. And the above training courses, we deliver it either virtual, online, that gives the benefit for locations, or like most customers today are still preferring above virtual, we also deliver that face-to-face. We do customized in-house training and seminars/webinars as we do now. And there will be, of course, some more free GMI webinars following. Besides that, we also deliver services in the life cycle of both the functional safety 1511, as well on the life cycle of the 62443. For those who are not familiar with the 62443, that is the cybersecurity standard that we are using in able to do the industrial security management and assessments. That's the book, and I will stop over here. Oh no, we have one more slide. There's also an online GMI academy that you can register, and this is a very similar approach on the YouTube recorded webinars which we had. But I will stop over here and I will close this, and I will go back into the questions and answers which we received, which I should also have somewhere available. Mauro, let me do a couple of clicks. Here I am, do again share. Now I have, of course, to share the correct one, which is this one. And then I say start. Here we go. All right, so as Mauro was saying, during your registration, we have received a number of questions. Of course, there are like questions in there. What is the weather yesterday? Well, I cannot answer that. Last ball. I only picked the ones that I like to answer, which are only a few of them. I mean, that makes sense towards the topic of safety requirement specification. Could you please share the GMI Academy? I think this is also online, Mauro, but correct me if I'm...
This is a simple answer. This is available on GMI website. You will get through the GMI Academy. You have to register, and once you register, you get access to 5 or 6 or 7, I don't remember the exact number, of webinars on different topics. So it is by accessing the website.
Okay, very good. Okay, I'll let you answer this for the Netherlands, Mauro. I will start the first question. There was an engineer asking process safety time and civ response time relation. What is the relation between them? I briefly highlighted that, but I found this quite of an interesting, let's say, story, because during my years of teaching, which is now into my 17 years, so I start to feel old, which I probably am, but I had this question so often, and they always ask me, where does this come from, Tino? Why do you say 50% and not 60, not 70, not 50 or 30, whatever? I said, well, that was a good question like 10, 12 years ago that I was starting to think myself, why did we always use that the process safety time versus response time, that my response time needs to be 50%. So we take the process safety time divided by 2. And that was our target, to find instrumentation, including the logic solver, including the length of the program. And we were trying to measure that between sensing your hazard is happening to the moment we can isolate it, we can prevent it. Well, that time is called the response time. And you can imagine, response time is not the same for all your loops, not the same for all your applications. Like in chemical industry, that can be a very, very, very important item. In refinery, it's almost like we don't care. We have a huge tank, we fill the tank, and if the tank is about to be really full, well, you still have an hour to stop the pump, basically. So if you stop it in 30 minutes or you stop it in 20 minutes, we don't really care. But when you have a chemical reactor, and there the chemical reactor, the runaway or the exothermic reaction can happen so fast in terms of seconds, well, their response times are deadly. They are very important. So it depends again, what is your culture and your background. So process safety time is the period between the initiation of the demand and the hazard event to propagate. That's the process safety time. That means your process specialist or the process dynamics will teach us how much time do we get from the moment we can initiate a demand to the moment the hazard event will start to propagate or will start to happen. So my response time, as already explained, from my delay in my sensor, throughout my delay of my interface, throughout the delay of my logic solver, throughout the delay of my final element, maybe the size of the valve is important. You can imagine a huge valve, 10 inch, 20 inch, compared to a 2-inch valve, may have a different travel time, most likely. That means those are all kind of items, mechanical integrity, that we have to take into account. How fast can we go to a safe state? So response time is a time to detect the unacceptable process condition and to respond in time to prevent the hazard event from occurring. Now, where is this wisdom coming from? Well, the wisdom was always coming from a document. For those of you who are familiar with the ISA 84 committee, the safety committee from the ISA, there is a technical report number 4. And technical report number 4 has been reviewed or have been revised according to the edition 2 of the 6.15.11, because you have to know that the ISA 84.01 document has been renamed in 2018 to the ISA 6.15.11. That means, although we still refer here to TR technical report based on that 84.01 standard, it's actually based on the 6.15.11 standard today, but they revised or they updated the document in the year 2020. So for those who are a member of the ISA or senior member, whatever, you will have access to all the documents free of charge, providing you pay your membership. You can view the document, You cannot copy it. You cannot take pictures. You cannot take snapshots. It's very cleverly website driven. That means you have to go on their web. You can view it. You can read it. You can do electronic search. But again, you cannot copy the text. So the reason why I actually have the text in here is I actually purchased also the document, because for us, it's also important that we can do than just viewing and searching on the web. We need to have it with us when we are traveling. And I took the text. So this is a text coming, a one-to-one short text from the standard. A system engineering rule of thumb. That is how it's described here in part 1, which is the Annex Q, item 5.3. They say a system engineering rule of thumb for designing a SIS for all these years is to design the system to use no more than half, between brackets 50%, of the process safety time estimated for the fastest scenario each SIF is being designed for. And again, that's here the reference which I have been highlighting. All right, I know there are a few questions in, Mauro. Do you want me to read the questions first or continue?
Well,
okay.
I would recommend to finish the question and answer during the registration, and then...
Yeah, the first question is actually related to my first or my previous slide. Let me first...
Okay.
Is there any reference in the IEC document where it is indicated to have the SIF response time to be less than half of the process safety time? That's an easy answer. No, there isn't. It's a rule of thumb living as a myth in the industry of safety engineers. This is clearly coming from a technical report. That's probably also why I put here the reference and not from the IEC. The IEC definition is different. The IEC will also take into consideration diagnostic-based equipment. But if you do have the IEC standard available, if you go to part number 1, you go to section 3 or chapter 3, which is the abbreviation and definitions, you will see process safety time defined in there. Right, and the second question, is there a time allowed for the ESD valve to respond in reference of the PST, most likely the abbreviation for process safety time and not purchase stroke time? So this is here a... is there a time allowed for the ESD to respond in reference to the process safety time of the SIF response time or the valve design response time? I'm trying to imagine what the question is really about. Well, to make it simple in my answer is that your action of your valve itself needs to be considered as part of your maximum response time. In other words, during the process conditions that your valve has to travel from A to B, that time based on design of the valve and based on the type of product that you have in that pipeline, well, that time needs to be considered as your worst case travel time of the valve, which is also part of my response time calculation. So you have to add up all those times together, the mechanical delay of your, let's say, your actuator, of your valve, of your stem, of the valve travel itself, of the solenoid, etc. All this needs to be calculated, estimated in terms to estimate how long will it take for my loop from sensor to final element to close. I found this an interesting question myself because it was a long question, but I just picked the one that was relevant to the SRS. How to consider aging factor in the SRS specification. And I was thinking, what does this engineer really mean with aging? Well, the word aging is clear, but how can I explain that in terms of the safety requirement specification? I need to move this here a little bit down. All right, so aging, in other words, wear out, is part of any instrument or any device or any system that you will use in your SIF. Classically, when I'm in front of a training class, many engineers are blindly focusing on frequencies, on PFDs, on probability to fail on demand. Then I'm asking the class, can all of you experts here define when you will die? Of course, people start to laugh, some of them. Some people start to get worried. I said, you don't have to worry because we cannot predict that. I cannot predict that. You can probably not predict it also, but why do you think that frequency number that you have used today to prove how good your safety systems are, why do you think they are correct? So aging is part of human life, but aging is also part of your valves, of your instruments, of your sensors, your barriers, your safety PLCs, etc. Now, believe it or not, any firmware-based device, the aging is not driven by the aging of the microprocessor. It's typically driven by not having the replacement chips anymore because the manufacturer stopped to produce this specific type of microchip. That means when we have a new firmware coming up, can be two reasons. They found so many bugs, or they are scared that in the next coming years, they may not be able to maintain their product line because they cannot buy the original chips anymore. Moving to a valve, for instance, if you buy a new valve and you never use it, or if you buy a new car and you never use it, the aging is also starting from the moment you bought it. Of course, the wear out is longer because you haven't used it. If you have an old classic car which you bought and you only drive it once every 10 years, well, the aging on the car is still there. Certain parts, like for instance the tires, if the car is parked in a garage and it's not normally monitored, etc., will also start to age. But the engine may also have a certain aging factor, although it's not being used. You may have to move it because if your cylinders are stuck, etc., that means that's also a certain aging. So coming back on this here, you need to make sure in your safety requirement specification, when you deal with your proof test implementation, two very important items here. One is called your mission time. That means how long is the mission time for your safety function on paper to predict the availability or the performance you try to achieve. In other words, what risk reduction factor do you try to achieve with that safety loop? And you need to make sure that your mission time is always shorter than the useful life. Now, useful life in the industry with end users, if you look at their final elements, you look at their shutdown valves, when do they replace a valve? Well, the simple answer is if it is broken, Tino. That means that the useful life on final elements typically is not being very clearly monitored. Because if you have to go to your management and say, can I replace this valve? Because we have this valve now installed for the last 10 years. And according to our according to the data sheet from our manufacturer, the maximum lifetime is maybe 12 years if you have a normal use from it. But yeah, we didn't use it much, so maybe we can use it for another 10 years. Well, what is all this wisdom of prediction, the PFD on your valve as an example here? If your mission time is a lot longer than the useful life. So aging is indeed a very important item to consider. Useful life from your equipment is a very important item to consider. And typically, the SIF description in the safety requirement specification, you need to actually prove that you reach a certain performance factor or a certain risk reduction factor. The maintenance persons or the maintenance teams with their procedures and with their proof test implementation will need to make sure that they can prove that that safety loop is still proving it is working based on the mission time that you're going to use that loop to protect or prevent your hazards from happening. Right, Mauro, I go to the last question. Is it a standard is it a standard format for preparing the SRS? In other words, is somehow in the industry a standard format to prepare an SRS? Well, the answer, of course, is no, there is not. It's always custom-based. It's always custom-based or either on the engineering company you are using. They have a trend in the industry that certain, let's say, EPC contractors, engineering companies will always use the same layout format again and again. You don't want to reinvent the wheel. However, there is no format in the standard saying they give you 29 items you shall describe and you shall include as applicable, but they don't give you a standard format on how to do that. Even the book from GMI with 29 examples item is just an example what could be the description behind the requirement from the standard. So There's no such thing as cut, copy, paste, and just fill in the blanks. Try to fill in as much as possible. You need to have a certain competency and know-how of what need to be filled in for our future, enabled to that the SIF will perform as required. Read the Good Engineering Guidelines, which is the part 1, chapter 10, which is the SRS. Read the chapter 8, which is not normative, but that's just a book from GMI with an example. And my advice would be follow some training. Make yourself competent, that you not just fill in the blanks, you really understand bullet per bullet what is the reason behind that. We also have live webinars scheduled for the future. So I took here a new snapshot what is coming up. So we have done this today. That's the one for next week. Why a standard power supply can be used in a safety intermittent function. But I'll leave this now to Mauro with the last poll question.
Yes. We have now a question for you, and we would like to get your feedback. Please do not consider my beginning. Sorry, I had the technical issue, but I'm sure you value the content of the presentation of Tino. And I see that this is going on exactly in that direction. So take the opportunity to thank you all very much. 65 minutes, so very well done, Tino. I'm sure you delivered a lot of good information to all of them. And let me stop the poll and share. I'm proud to share an answer between excellent and good. So that's another confirmation that we are. So again, as Tino was mentioning, if you go through the website, you will see which other webinar we are launching in the coming weeks. You have a chance to monitor, to watch the same webinar or many other webinars which are on our YouTube channel. And you will receive the presentation where you see also our contacts. So if you need any further information, feel free to get in touch with us. Again, thank you very much, and look forward to see you again.
All right. Thank you, Thank you.
More webinar. Thank you, Tino. Thank you very much.
All right.
Look forward to meet you again.
All right. Thank you. All the best.
Thank you. Bye-bye.